it's on the left. Why? Yes, exactly. Good question. Yes. Timeline. Timeline difference.
You can look it up online. There have been entire discussions about people remembering.
I remember six, but some photos on the internet right now show a four-person car. Because everything is possible. Everything is a possibility. So that was a car with six seats. It was shot. There was a motivation. Yeah, but as soon as I lost
it started off with better. So I always we have to add or the motivation.
I thought it was also
Getting started.
Hi, welcome. You can take a seat if there's some more. Laat me heel veel openstaan.
So, good evening everyone. Nice that you are all here today with us. I'd like to today. Thank you for being here and for the Binary.js Guild for hosting us here. Yeah, we really appreciate it, and the whole Binary.js Guild community to be here today. Also, good for all the live streamers that you're joined in with us here tonight. And Peter, if you're watching, make sure you get better soon, because we are having a great party this Friday. Coming to that, Peter is sick today, so I will be giving his presentation, and Jesse will give his presentation afterwards. Okay, so the impact and glory of GraphQL at Lifely. Yeah, we are Lifely. We are a digital agency. We are an architect in online, if you call it like that. We have been building web and mobile apps for the past 5 years. So we're looking at the context of building full stack applications for our customers, our clients. And yeah, in that context we're going to look at what GraphQL meant for us and how we came to using GraphQL like we do today. So a little bit about our stack history. We started off with a stack of PHP using the REST specifications with Angular. So we started off immediately with an API and frontend framework. So the backend and the frontend were decoupled. We used Symfony framework for that, but soon enough we started building a spin-off of Lifely called Berlin, and we started using Node.js there because we were like, okay, Node.js was this was like 4 years ago, and it was like, okay, Node.js is the cool kid on the block, right? And we thought, okay, let's go. We will try, and we will use Node.js. So we started off with that. Well, it worked pretty great for us at that moment, until one of our customers came and say like, okay, I want this application, but you have no choice. You have to build in Meteor. So we were like, okay, we just moved to Node.js, and now you kind of demand from us that we're building in Meteor. So that's how we really came to build an application in Meteor. And Meteor, I don't know who knows Meteor here. Oh, okay, that's quite a lot of people. Meteor uses a DEP protocol to communicate between backend and frontend, like server and client. And this is all made real time and stuff, so you don't have anything to do with REST anymore. And we use the Blaze, it's like the templating engine that Meteor uses. So we use that instead of Angular at the time. After that, we were like, okay, real time is cool. It works, well, it works pretty great, but you don't always want to have real time stuff. And real time stuff is also pretty heavy on your servers and on your backend. Because it works like if you update something in the database, it will automatically update in the client, and if you look at all the steps that it needs to be, or it needs to take to get there, it's quite a heavy load. So we thought, okay, well, Meteor as a framework is pretty okay, so we started using GraphQL instead of using the standard DDP and use React with that. But we soon found out that like Meteor is, I don't know why, but somehow it's pretty heavy to build, and we had a lot of. I see some nodding. Okay, yeah. So we had a lot of problems with RCI and Meteor not building, or Meteor running out of memory. I think it sounds familiar. So yeah, in the end we chose, okay, so Meteor, you know, we didn't use the real-time stuff, we didn't use Blaze anymore. What's left of Meteor that we will still using today? So we were, okay, let's move from Meteor back to Node.js again, but we kept using GraphQL and React. And this is mainly the stack that we use today. It was JavaScript for most of the time, but like the last couple of months we moved to TypeScript, which I highly recommend everyone doing. Yeah, TypeScript became pretty huge already, so it really helps with all error finding and stuff. And if you want to ask anything about that later, do it after the presentations, and I'll gladly tell you everything about that. So okay, so as you can see, we've got quite some experience with like non-standard APIs, not only the REST API but also DDP, and we've also built quite some applications on GraphQL already. So I remember like back in the day, it said he couldn't be here, so repeat. But back in the day, he was always like, okay, we have to adhere to like every REST specification that's there, and we have to build like the application that you know, that's perfect. Every developer that comes in and knows the REST specification should be able to easily use this API. And yeah, that was really cool. But soon enough, we found that REST had some problems that we were like, okay, we were always trying to figure out how to solve these kind of issues, but we never came to like the real solution. Some things, you know, that were problems were like things like embedded queries, because you're like, okay, we have, for example, a Twitter application. If you look at the Twitter user profile, then you would want to get the user, but you would also want to get their tweets, and those things are, you know, if you look at it from a REST perspective, those things would really be different resources. So imagine something like, I don't know, if you take Facebook for example, and you would have built like the whole REST thing without cache, and I don't know, then it would be immense how many queries you have to do to get all the data on the page. So that was one thing that really kind of bothered us. Linking entities is something in a similar fashion. We had some problems with that, and especially this is a lot better in GraphQL. So we're looking into that later. Yeah, things like, okay, if you take, for example, you take Twitter, okay, if you, I find Jesse's profile, and then I press the follow button. You know, I could do a post to REST to set user/ID/followers with something like his ID, his user ID. But what happens if I, you know, there's a button next to there that says like, okay, send me mobile notifications. Like, what do I need to do in a REST way to say like, I want mobile notifications? It's something like a setting or something. It should be possible, but it's not really clear what kind of thing, what kind of REST endpoint you would make of that. And then there's also like REST calls, post calls, that not only create one entity, but for example, create multiple entities. There are a couple of scenarios where you could think of where this will happen, which is a bit odd if you try to follow every REST specification. Yeah, documentation is also, if you are going about documenting REST API, then you have to write it besides creating the REST API itself. So there are probably packages and some tools that can like use reflection in your code or whatever to see what kind of REST application you're building and make documentation out of that. But this is something GraphQL does really well, and we'll get back to that later as well. And yeah, versioning is a bit vague, but it's also a bit of a problem, which is in itself in GraphQL also a bit of a problem. Yes, that. So what's GraphQL? GraphQL is a query language for APIs. I'm quite interested in how many people here know GraphQL. Is it all here or? Okay, okay.
How many of you tried something to try to build something in GraphQL? Cool.
Okay. So if you take, for example, this is one thing examples I just gave. Like, if you take a Twitter profile, you will have to do three requests to get like the user, its tweets, for example, and for example, his followers. Then you have to do three different calls to the backend, 3 different REST calls. But if you take instead, like, this is GraphQL, and on the upside, you can see like a GraphQL query. I hope most of you can read it in the back. But this is like a GraphQL query, and how it works, you kind of give like the power of deciding what the client needs. You give that power to the client, so the client can just request whatever he needs, and the backend is like concerned about performance and stuff. But in that sense, you only have to do one request, and you will get everything you need in one response back. Okay, so GraphQL is also a really great tool for collaboration between front and backend. This is also because GraphQL is inherently documented, which we will show later. That if you've never seen it, it's like really powerful, which makes handover to the front-end team for the backend is easy. What we've seen is because we were building our backend in JavaScript and our frontend as well, that we've seen that like a lot of our frontenders are able to create stubs, contracts, so they kind of create like the GraphQL query that should be performed and what they are going to need. And I'm a backender myself, and we can use that information to like build a backend. And this is something that is, yeah, I would say it's pretty powerful in GraphQL. And okay, there's like Apollo Client. It's a one-stop library for front end, so that really helps with integrations in the front end of GraphQL. So okay, yeah, we've used GraphQL in a lot of different ways because we didn't like immediately move all into GraphQL, and this gave us a couple of like architectural options. For example, this is one of our applications that use a GraphQL API, but it solely uses a GraphQL API. So inside the GraphQL API, we directly do our calls to the database or do anything else like Amazon or anything else we need. So yeah, that worked. That's kind of a replacement of the REST API, right? But we've also made an application where like we had to access our own database, but we also had to access like external REST APIs. But we want to make one API for our own front-end team. So we used GraphQL, and we did some external REST calls to make sure like we called the right. And in this way, we made an integration layer between our own database, our clients like REST integrations, and our own clients. Yeah, so they can use it easily, and they can make use of the documentation that GraphQL provides. Okay, and the last one is GraphQL as a mini API for server-side rendered application. So we have one big-ass server-side rendered application, and we're like, okay, we have to build an API, and we had some experience with GraphQL at the time. So we started building a GraphQL API, and we used like tiny bits of logic that were used inside like the server-side code instead of like letting the server render the stuff. We built our own client with React, and yeah, we could easily create a GraphQL layer between those two. Like some pages were still server-side rendered, and some pages used the single-page application with GraphQL as a backend API. This was our application. But of course, yeah, there were a couple of challenges. One of the first things that like we've seen a lot is like, okay, GraphQL is pretty new. Why would you start using that? Because REST has been in use for such a long time, and now you come just using GraphQL, which is cutting edge, so it brings all the risk. But we've seen that like places like GitHub and Airbnb start using them and started using them successfully, and you know, I know all of you know who GitHub and Airbnb are, so they use it and they kind of show that GraphQL is able to run on production without too much problems. Another argument is, okay, so if you build an application right now and you build it in REST, like REST is the specification that is the core, the heart of your API. Isn't it like if you're going to switch something like that is such at the heart of your API, isn't that going to take ages to just do, and you kind of have to rethink everything you do? And we found out that we tried and we didn't have much problems at all doing all these things. So it took about 1 month before we actually had something. Of course, we started off and we made a couple of mistakes, which we'll get to in the next presentation that you shouldn't be making after you've seen the presentation. But yeah, okay, so we still kind of want to do real time, but there are GraphQL subscriptions which help you do a real time as well. So that's not really a problem. And this is kind of like the thing that we're going to talk about is if you implement GraphQL like the backend GraphQL in a wrong way, you'll make like a lot of mistakes about how you get your data from the data layer and how that impacts performance. But we're going to take a look at it, and yeah, yes, we'll give the main presentation, I'll give the demo also on that. Okay, so yeah, that's really like the impact of GraphQL and how we came to use GraphQL right now in Lifely. And yeah, that was, I would say, my, but also more Peter's presentation. And yeah, thank you all for listening.
I've no doubt that there are questions. Yes?
You were saying like you, instead of doing the 3 REST requests for Twitter, for instance, you do them all at once.
Yes.
But I can imagine that means that your GraphQL response time will be the one of the slowest of all of the 3 queries that actually are aggregated on the server or wherever. So normally I would imagine I load my user, I get at least its bio, and then I do some skeleton UI and I get the rest. And now if the rest takes long, I'm stuck in a blank page.
It's true, yes. But imagine like what I said, like you give the power back to the client. So the client could decide if like some of the data is behind the fall, then it can do 2 GraphQL requests. It doesn't matter. It can do 1 GraphQL request to get like everything above the fall, and then just do another one that gets the data below that.
So in practice, turns out that we are like every single route does its own GraphQL query. So when you have tabs and subtabs, and even that page has subtabs, then we mostly do queries on every single level of route. And even then, some different paginatable resources are present on one single page. So the main table, for example, users or something, can have filters. Filters by, for example, cities. And users are separately paginatable from cities. So you have to do 2 GraphQL queries, because otherwise you would, when you scroll down, you would request the first set of data, which is not a table. So you have to, it turns out in practice we are really doing much separate GraphQL queries, but it's way less than we would do with REST, because all the resources you need for one table are in one request.
Yeah, it's like the client is more responsible for what's happening.
Yeah. Instead of the server.
Yeah, exactly. So.
Someone else? Yes?
Yeah, first of all, thanks for sharing your insights. Definitely helpful.
at the beginning you mentioned that when you use a REST API, for example, if you would like a new follower from the Twitter feed, you could make a post request, and then you would, that resource would be assigned to that other resource of the user. But how did you? There was another button which was like more of triggering an event, like I would like to get the notifications. You mentioned that there was a disadvantage in REST, that there is no like official or proper way to do this. But how did you solve this, and how did you solve this with GraphQL?
Yeah, well, GraphQL is actually a whole other spec than REST. So it's not that you have to execute queries or mutations by resource. It's not that you must couple it with entities. It's mostly decoupled from entities, and you can decide on the server if you would want to do that. So unlike the RESTful specification. So in this case, we would just create a mutation called what was it? Turn off notifications.
Turn on mobile notifications.
Turn on mobile notifications. Just call it like that. Turn on mobile notifications with some arguments.
Okay, so you can model like mutations or actions or anything you want.
Yeah.
Not resources per se.
You can also do that in REST, but it's like it doesn't really feel like REST if you do it that way. And then that's kind of the thing. In GraphQL, it's okay. I mean, you can call it if you want.
Thanks.
Yeah. Welcome.
With GraphQL, you just delegating the client side all the responsibility instead of let's say hiding them on the server side. And if you don't stay strict on the Rastafarian approach, with REST you could do anyhow not strictly false. It's not that the protocol itself is blocking you from doing that. So isn't that just a switch of responsibility? Isn't that dangerous?
Switching off Rust?
No, the switch of responsibility from the client, from the server to the client. So at the end, the client is more responsible for doing stuff, and then
well,
go wrong.
In practice, you the fact that in REST everything is like namespaced on resources.
Sorry, but it's not that. Is that you are suggested to take that approach. You can even take other.
Yeah, but that would be hacks for the RESTful specification. It's not REST. It's not really REST. So you
what
have
is
to.
REST? Aren't you acting a bit too much Rastafarian?
Yeah. So your real. So I'm sorry. Can you repeat one more time your question?
Yeah. The difference that I see is not that you can use a not resource-oriented protocol, because you could do that with REST without any problem.
Yeah.
I mean, there's nobody coming with a gun telling you shouldn't do that.
Yeah.
It's just that you move the responsibility from the server to the client. That's the big difference I see is here.
Yeah.
And isn't not that a bit dangerous?
Yeah, so then I understood the question correctly. What I think is that when you have to, when the things you want to do, for example, disabling notifications, let's say you have to run two REST calls to do them when you are holding tight to the REST specification, then the client is responsible for doing those two calls. Instead, in GraphQL, you can make one call of that, and the server does apply two changes on different resources because it's one meaningfully named GraphQL mutation. So in that way, the responsibility is more with the server, but what we meant with the responsibility to be more with the client is that the client can
can freely choose which resources on which page are being called. That's what we meant by it, and not really the correlated mutations that have to be called to make everything work. So it's not dangerous at all. Did I answer your question?
In some sense, it's not really different than REST, is it? Because in REST you can do like 100 calls if you want to REST client.
Yeah.
You will specify a schema in GraphQL, so you put a boundary on what client can.
Of course, like okay, the
So
responsibility
it's
for
not in that sense.
sorry, the responsibility for performance is like always in the backend, right? So with GraphQL, that responsibility is still on the backend, but you allow like the front end to do things that it's not able to do if you're using REST, because it has to do like 5 calls. But in GraphQL, it can do it in 1. But like, I don't see why that gives like a dangerous thing, because of course you can request a lot of stuff in 1 call in GraphQL, but you can also do 20 requests in REST, and I don't see a difference between those two.
Well, there is one when you're using mobile phone, because then the latency of doing those.
Yeah, of course, performance-wise. I mean, if you look at it from what's dangerous or not,
No,
I mean,
of course not.
the client is always like able to DDoS if it wants to, you know, and it can, if it makes an enormous GraphQL query, which is possible, the backend should handle that and should say, okay, you're asking way too much information, get out and try something a bit less heavy, right? So I think that's like still the responsibility of the backend. But you also, okay.
Yeah, with danger you also have, for example, access control. With REST, it's easier to monitor the access control. I think that might be your question. But if you give all the power to the client, he might be able to request resources. He's not allowed to via REST.
True.
So
this is a really hard topic, but in the end, if you call, like, if you look from a code perspective, if you call like a REST endpoint, you will call some function, right? And it will, and on top of that function, there's something like, okay, you are allowed to do this or you're allowed to do that. What happens in GraphQL is, okay, either you give an error like, okay, you're trying to access this but you can't, or you just return null, like, okay, you're trying to get, okay, I can give a better example on the next presentation where we really see like GraphQL in action. But if you, for example, ask some sub-entity of the user, and that's probably, you can access like 10 out of 100, you only get back 10. Yeah. See? And that's still the responsibility of the backend to give back the data that the user is allowed to see. But it remains a somewhat harder topic. That's true, because if you make a really large query, then how are you going to determine like, okay, like all the way in, you know, can the user still see this or can it not? That is a problem.
Yeah.
But it is possible.
I've seen a question over there.
So it's interesting for me how in practice you protect your backend from too heavy queries. So for example, if the client is in the query requesting too much of data,
Yeah.
so how in practice you take the situation in the backend and protect them against it?
Sorry.
It doesn't matter. Like my hearing is not really good, so I'm asking him what the question is.
Yeah, I want to repeat the question for the camera, so for the streamers, because I'm so sorry. Can you repeat one more time?
Yeah, no worries. So how do you protect your backend from too heavy queries coming from client? So if a client requests too much data.
Yeah. Oh, so limiting the amount of data.
How do you detect on the backend there will be too much data? How do you detect such situations in practice?
Yeah, you can. We didn't really encounter that problem yet because, in fact, the responsibility of requesting how much data is being retrieved is completely with the front end. So the question was, how can a server limit the amount of data being requested by the client? And I think if someone is evil and wants to do this, he could do that with with so much types of server APIs. And for this, we are restricting it because the front end is not that just requests not that many data. We program it like that. So is your question about evil attackers, or is your question about front-enders?
No, my question is about the fact people are not all the time evil, but sometimes they just make mistakes.
Yeah, people are not all the time evil. No, I understand. Okay.
It's true, and it's possible. You can like limit everything. If you go about asking users, you can always say, okay, you can only get 10 at a time, because right? And if you ask something in those users, you can just get like also 10. And this most of the time isn't like, okay, if you ask users and their tweets, like you can say, okay, you can only get 10 tweets for each user, but you can keep on doing that. And it is a problem indeed. And it's harder to solve than it would in rest, yes.
I think you can do a request monitoring.
Yes.
You can do a timeout, just give an error if your request runs for more than 10 seconds.
Yeah,
something there.
a timeout on global level. Yeah.
Another type of maybe the same problem, but what if you request not all the tweets, for example, but if in a single query, in a single GraphQL query, you request for too many entities which are bound to each other by reference. So I'm just trying to imagine how I would extract all these entities for the response from the database if it's relational.
Yeah, I think this question will be completely answered by the next presentation.
Sorry, I can answer the question.
Oh, yeah.
You can set the complexity to each node. So and that complexity can be, the resolving complexity can be calculated before you run the query, and you can reject the query based on that. Let's say retrieving a user has the complexity of 1, but retrieving a photo of a user has the complexity of 5, and you set the maximum complexity to 10, then you cannot retrieve, let's say, 2 users who have 5 pictures.
Yeah, so another way to solve it is by restricting the complexity. I'm just repeating for the streamers. Okay, so we're running a little bit out of time, or we're just on time. I think we should hold a little break, 5 minutes, and come to us if you have more questions. We'll be available. Thank you.
Like once a week. These are like once a week. Ja, zoals
But I hope after that you will talk to other people because that's kind of part I published the GitHub, but I never paid attention at 6:30. I was at 4.7.
Oh, welcome back. Okay. Well, he's Bryan. I'm Jesse. We are not Peter this time. And this talk is going to be a little bit more in depth in GraphQL. I suppose most of you are waiting for that. So this is about optimizing the way GraphQL talks with the data layer. Yeah, well, actually, how it optimizes talking with the data layer, that's actually what we are getting at the very end of the presentation. The last part. The first part is mostly about what the problem really is. And for that, I will carefully explain step by step how a GraphQL query works, how you implement it in JavaScript. But it could be PHP or Python, it could be anything. But for this example, we will use JavaScript. So, let's pick a case. Imagine that you go to Schiphol tonight. I wish I would. No, just kidding. This meet was great. Imagine, okay, imagine Schiphol. Imagine you were going to Schiphol with a suitcase. What is the first thing you do? Oh, a little bit. Okay, what's the first thing you do? You go to a flight departure board. Those big screens telling you where the check-in is and where a gate is. So that's the first thing. And for that, there's a lot of data coming in. It's flights, and there are gates, and there are check-ins, and there are arrival airports, and there no, not their departure airports, because that's always Amsterdam. So, okay, let's bring it into, let's talk about the data model first before jumping right into GraphQL. So we need for example, SQL data model. For this, so you start with a flight. That's obvious, I think. The flight has to arrive at an airport and also depart from an airport. So you have two IDs. So this is actually, correct me if I'm wrong, a one too many and another one too many relationship. Because there are two fields. Was that right? Probably. Okay. And then you have the passenger. And the passenger flights. So the passenger has a flight ID. But the passenger has always have to fly back. So that's a many-to-many relationship. With this, I don't know if the baby is big or the airplane is very small, but yeah. Well, so this is a many-to-many relationship with a lookup table for flight ID and passenger ID. So, okay, this is pretty straightforward. We're not getting any more complex than this. Yeah, let's build the API. Okay, so we have 3 different types. You have the airport type, the flight type, and the passenger type. No more. Yeah, well, the airport type contains a name, departure flights, and arrival flights. And in the data model, actually in SQL, you don't see these 2 fields. These 2 fields are actually introduced in GraphQL and called in a special way. It's not already in SQL. And then the flight type, well, they have, the flight type in SQL has a name, the departure airport ID, and an arrival airport ID, but not the actual airport object. And a link to passengers, which are also not directly seen in the column, because yeah, you have a many-to-many relationship with a lookup table. So that's also a kind of dynamic field. Whoa, it went fast. Spoiled. So the passenger type has actually in SQL only a name, but you can request it. Oh, and yeah, only a name, because the flight has passenger table has flight ID and a passenger ID. So the passenger has only a name. Well, the demo. Bryan will show a little bit of the queries.
Okay, so yeah, we built ourselves a little application.
Yes,
is that close enough? Okay.
Maybe close to the Documentation Explorer? Or?
Yeah, I kind of want to show that, like, for the people that listen to the you all listen to the previous presentation. So we can see like this thing on the right side is fully generated from the API we built. Like, we didn't document anything; it just automatically self-documenting. So in this case, we have a couple of queries. The main thing is we have a flight and we have a passenger, and we should have an airport. Do we?
No airport?
No airport. No airport. Oh no, these are the queries. Okay. So
no problem.
Yeah, I'll explain a bit later, more in depth if you want.
So these are root fields you can request. The root 5 fields.
This, by the way, is graphical. It's used a lot by people that like implement GraphQL backends. You can easily just write something and get data back. So I'm going to write a query and I'm going to request the flights. It also has auto-completion, and that's also based on the self-documenting thing in GraphQL. So I'm going to request the flights and I can get their names. So there's the data. It's like all the flights with their names. But for example, we also expose like the ID, so I can also request the ID if I want to. But I can also leave it if I don't need it. But for example, like, okay, a flight has an arrival airport, right? So we can request an arrival airport. And from the arrival airport, we want to know the name, right? So now in the data you can see, I'll close the documenting thing for a second. You can see now that it's also giving back like the arrival airport with their names. And I can do the same for the departure airport. That's also going to give me the departure airport for every flight. You can see here like this, okay, this is GraphQL, and this is how you can use it. And yeah.
Yeah, that's pretty much it.
Yeah, that's pretty much it. Yeah. You'll have to wait for a second. No?
Yeah. More demos coming up. Oh, remote. Okay. So I will jump a little bit to the key benefits of GraphQL first. So I think to most of you it's already pretty clear, but I will run very quickly through them. The queries are flexible, as you just saw. You can ask for multiple resources in one single request. Yeah, well, every single field can have arguments. You haven't seen that yet, but some of you already know it. You can have any field, for example, the departure airports, you can pass arguments to it, for example, to filter it or something, and any field can have arguments. So it's completely compatible. Yeah, and the client decides what it gets. So, okay, that's cool. Now, when does GraphQL get tricky? Okay, well, when queries are flexible, it gets tricky. When you can request multiple resources in a single request, then it gets tricky. And when a field can have multiple arguments, when any field can have arguments, then it gets tricky because so many possibilities. And when the client decides the tree, so the server is completely out of control. There's actually the same list. Oh, I see it now. Nice. Well, let's do a deep dive into the code to explain the problem a bit more. Well, let's start from the very beginning. We query a flight. Let's build this. So I define a flight query, and I say, okay, it returns a string, and it's hard-coded to AC12 because all flight numbers are AC12. Okay, that's not really useful, but this is how a simple message communicating with GraphQL actually looks like. When you're not requesting the flight, then you're not getting the string. So the client just receives an object with key flight value AC12. But we will pretty quickly want a subselection of fields. Not only the name, but maybe more. So let's put name as a subselection in a flight. So then you see here the GraphQL string from before. That will be replaced by the flight type. And the flight type is a kind of predefined object what a flight can contain. For example, name. We will get to that later. So, and the resolve will also change. It returns now an object with name AC12. But when the flight type doesn't contain the name, then the result to the client will also not contain the name. Okay, so let's plurify this. Flights, and a list. Okay, so this way you define it should be a list. And yeah, wrap it in an array, or multiple objects in an array. So this way it's now plural. But let's integrate this with this. Let's integrate this with our database because it's still hard-coded, not very useful. Okay, so we do a database call. For now, assume that it's all synchronous code because normally we would put async here and await here, or yeah, well, maybe if this returns a promise, then it would work already. No problem. Okay, so this is some integrated code. Okay, now let's get to, the integrated code just returns kind of array with 3 objects. And every object contains name, and as I said before, the arrival airport ID and the departure airport ID. Okay, so this is an example piece of data. Okay, let's take a look at flight type. Well, the flight type is just a predefined object specification. So what can the client ever receive and what can it not receive from the object. So if a field misses here, for example right now, then the name will not be in the GraphQL documentation explorer, and the name cannot be requested from a flight at all. So let's add it. Let's add a name type. So next step is that we will probably want to retrieve the arrival airport to show on the big screen in Schiphol. And an airport can contain a name. So let's add this there. All right, so far so good. It has an airport type, and that's pretty much the same as this one, but only with the name and another name itself. Okay, but as I said, the arrival airport is not inside the flight object yet because only the ID is there. So I have kind of to resolve it. So as you see, the relationship, it's not really well readable, but it's actually a snapshot from an earlier slide that the relationship is through the arrival airport ID, and this was the object, and the arrival airport ID is in the object. So with the resolve function, we are able to transform the ID actually into a real airport object. And we have to add this resolve function because otherwise the value would always be null or undefined. Okay, so far so good. Actually, resolve functions are always this by default. but it's not really necessary, so you can leave it out. Because the root object is just what comes in from above, and this key is retrieved by default from the object. So this is the default resolve function, but you can leave it out. All right. Now is the question, if we have this query, and let's say there are 3 flights, and all the 3 flights have the same arrival airport, then according to this code, how many SQL queries would run? We have A1, B2, and C4. Hence for A. Nice. Hence for B. 4, 5, 6. Hence for C. Most of them are saying C. Okay. So I assume that, no, I assume nothing. He's gonna demo.
Okay, so yeah. Let's take a look again at what we have here. Let me see. Okay, so we are going to do the same query as just showed. Can you still all read it? Yes. This is the same query as just showed, right? It's getting all flights, and yes, there are 3 flights in the database. And it's getting the arrival airport of each of the flights. I'll make this V1. It's just, you don't need the V1 and stuff, but I made it for the demo. So, if I request these, you can see it, okay, we're calling the database without optimizations, and we have here.
Even inzoomen op de linker.
Okay.
Oh,
my ASCII is going to break.
Just rerun the query.
Oh, what it is, yeah. So
you don't have to read this actually.
It's not. No, it's like the count that is important. So how many queries are this? 4. Yeah. So the good answer was C, because like we get the flights, we get 3 flights, and for each flight we get the airport individually, because we don't know upfront like if we request the flights and if we're going to request like the airport. We programmed the in this demo we program it the way like if you get a flight object back and you ask the arrival airport, then it will get it from the database, but like there's no optimization, so you'll get 4 queries, and so the answer was C.
Yeah. So sorry.
What about 3? Because you have 3 airports, right?
Yeah, we have 3 airports, but that's what these 3 are. And the flights are requested all at once because you have 1 query to request all flights. So the first for the flights and the last 3 are for the 3 separate airports. And this is with 3 separate airports for every flight. Because GraphQL goes into a flight, resolves the airport, goes into another flight, resolves the airport, and for the last the same. So this is with no optimizations.
Exactly, and so all 3 flights are from Schiphol to London Heathrow. So you'll see we have 3 flights, and it will get like the airport, which is Schiphol, 3 times, but it will get it 3 times because it doesn't know upfront like, oh, we're getting 3 flights that are all from Schiphol to. We don't know that, yeah, at this point.
Cool.
So
okay.
Yeah.
Next. Okay, so there is a solution to prevent from requesting 3 times the same airport, and also a solution for when it would request 3 different airports. Doesn't matter. It just fixes something. Let's go into it. Okay, so we have this flight type from the previous slides, and the flight type resolves the arrival airports, which causes what I explained to him, that every time you go into this object, this will be resolved, and the next time too, and the next time too, without optimizations. So let's say we don't do this call. We take a look at 2 more arguments coming in the resolve function. the second argument is just an object with arguments you can pass to this field, which are not really pointed out in this presentation. So come to me afterwards if you have questions about it. And third argument is context, and context is actually defined top level, shared across all resolve functions in GraphQL. Context is always the same. So you can put something like caching optimization libraries into it, which is done by data loaders. So let's, for example, say we have the airport's data loaders object set on the context object. We have all done that before. And then we load the airport by just giving it the ID. And with that, the data loader will just wait until all IDs are in or are given, and then it will combine all the IDs into one query in SQL, and then it will run the query once and resolve all the promises. So actually, when you have another resolve function requesting some airport with some ID, then it will go into the same query, and that GraphQL and database couple code, that is what you write yourself when you implement the data loader. It's not predefined in the data loader. So the data loader can be used with several types of databases, but it's made in JavaScript, so it's only for JavaScript, or TypeScript of course, but that TypeScript is just a layer above JavaScript. So this facts given, how many SQL queries will run now? Hands for A, 1. Okay, 2 guys. Hands for B, pretty much. Hands for C. Okay. Oh, Bryan.
Okay, let's take a look. So we're going to run version 2, and
it's raining.
Indeed. The answer was B, right? 2. What you can see here is, like in the previous example, I'll just show that one really quick. It's getting like the airports one by one with the same parameter. I'm not sure if you can read it, but this says 2, so it's running 3 queries, exactly the same queries. And if we use the v2 that is implemented with data loaders, you'll see that it only requested that airport just once, because it only needs it at one time, and it waits until like everything is known, and it had just that number 2, that is the ID of the airport, and then does the database call to get the information we need.
Yeah.
So this is the first optimization using data loaders.
Yeah, and we actually saw in production that this optimization was really necessary for most of our cases, and it was for the big part already enough for most of our cases. So let's say you have a big page, a big table of books with all the same author, then it's just useless to call for every row the same author to the database. So only a single user using the application pretty intense already result in a high CPU in the server because so many queries are run. But we thought in a REST way, or you could, okay, maybe not REST, but you could optimize this further. So we took a look in GraphQL, in the possibilities of GraphQL and everything coming into the resolve function. Remember this one? This is the root flights query, not the flight type, but the root flights query, where we just find all the flights coming in. We take that away, and oh well, this is actually the same. Don't mind the previous one. This is still coming from a database. So you have these arguments we saw earlier. It says root value here because if this is a root query, then the root value will be probably null or undefined, because in the first queries you don't pass any root value. But the beginning of the graph has no root value, and that's the reason why we call it root value, because it has no name. Then you have arguments and context, you saw it earlier, but there's a hidden fourth argument called, we call it info, but it's actually the abstract syntax tree of the current query being run. And the abstract syntax tree is kind of a JavaScript object containing all the information about the whole query being run at that time. You can, when you click through it, when you log it and you click through it, then you will see that all deeper nested fields are also in there, and their arguments and what they mean, and you get all the information up front. This means that using this information, you can compose your query, pre-compose your query a bit smarter. So in this case, we could join the airports with SQL into our flights query. So I say join because SQL now, it can be any aggregation with any type of database. So this join from GraphQL-info function we wrote, it's something not public yet. We tend to, but it's still experimental and such. It's just to give you an idea that this is a possible solution. So this way, because the airport is already in the source object when the resolve tree goes into a flight, you don't have to resolve the flight, the airport, because it's already there. Because the join info from GraphQL, info, already embedded the airport up front. You could, let's get back, you could wrap this in an if statement. If no flight.arrival airport, then do it, otherwise don't. And that way you keep this flight type compatible with with sources which did not join this up front. For example, if you request from a passenger all the airports he's been to, then you may forget to call the join from GraphQL info optimization function. And when you forget it, you want to make sure the arrival airport is resolved anyway, not optimized, but it should be always there. So for that, you could wrap it in the if statements to make sure it resolves anyway. Well, hands for 2. Almost strict. Hands for a half. Hands for 1. Cool. Okay. Bryan?
A lot of people don't know. I saw a lot less hands than like everyone. Okay, so let's take a look. Again, we'll run version 3 this time. And version 3 has like the code he just showed. And if I run this one, it kind of like how it shows. It looks like it's still 2, but it does a lot of automatically does a lot of S. Like if you know SQL, like it's renaming fields and stuff. But that's one query, and it's doing it like left join here to join the arrival airports on the flights, and all it's using is like that abstract syntax tree from GraphQL. It's parsing this, and it's seeing like, okay, you're requesting the arrival airport. Okay, I'll make sure you have it before you actually are in the resolve function of the arrival airport, and that way I can also like request the departure airport. It doesn't really matter. It will just join that on, and yes, most of you probably will be thinking, ooh, that's like performance-wise, but then you have like the same problem that we discussed earlier, and that you have to like limit everything and stuff. But yeah, this is a solution that works pretty well for us right now. Yeah. It speeds up development time like tremendously. Only thing is, authorization still has to be done on resolve level of a type. So we would still have like the flight type. Yeah, you could probably show that one again.
Yeah,
yeah. Yeah, so here we removed like the resolve, but in that resolve, like the data is known, so you can do flight.arrival airport and it will be there, and you can use that information to determine if the user can actually access that data, and don't return it if you don't need to, but the data is already there. So that's optimization, and you can use like still use authorization, and at some points it's even better to do things like this, because yeah, you have more data, you have like a better way of determining what users can see and what they can't. Yeah, and it's working pretty good for us so far. So
yeah, so you can still add a resolve function. You don't have to. You can add a resolve function to do authorization and such, but you don't have to. Okay. Yeah. Well, so this model, this is a visual representation made by the Electron app GraphQL-rover. It's very cool. You can clone the repo, run Electron, and then you can enter any GraphQL endpoint, and it will show a visual map in Canvas. It's very cool. Everything is clickable and works pretty well. But this is our model, and it's still pretty simple. You can see the relations, but it's still pretty simple. Imagine doing this with a large existing, a large product with many queries and many fields. Well, I tried one time to visualize it using D3. So I tried to visualize the GitHub GraphQL API. And what you see right here are the centers are all GraphQL types, and the dots around the center are all the fields of that type. But I disabled all the relationships because you couldn't see anything anymore. It was just one filled up circle because all the relationships going anywhere. And in GraphQL, yeah, you don't know where the client comes in, follows a path to another type, and gets out. And that brings a lot of performance issues and authorization issues with it. And therefore, this solution we made up is pretty applicable because it's just smart and it just magically joins anything you want. So we will see how it runs in production. Thanks for listening. Cool.
Oh, yeah, can you do one more thing? The previous slide.
The previous slide?
Yes.
Oh, sorry.
So, yeah, I just wanted to see this thing, imagine, it's not like Jesse, went through a GitHub documentation or anything to just find out what the nodes are and all their fields. This is all based on like GraphQL self-documenting stuff. So I can fill in like one of our production API URLs here, and it will show this thing like almost immediately. That's just how GraphQL works, and that's one thing that's really powerful of GraphQL.
Yeah, when you use, for example, the JavaScript implementation of GraphQL, you will magically get one query by default. You don't have to define it. It's called the introspection query, and in the introspection query, all the data about your whole schema is in there, and that's actually the query being run by the Document Explorer when you take a look in the graphical. And that's the same query I used here to get all the nodes and try to render it in 3D, D3.
I can show it really quick. I'm not sure if you want to see like the introspection query, but
oh, the introspection query itself.
I could probably show it.
Yeah, just a network step in.
Does anyone want to see like the magical introspection query? Okay,
yeah.
one guy. Yeah, I'll do it for you. No, it's if I just look at the network tab here and I'll refresh that page. Let me close the console.
Je kan die ook zoomen.
Wat?
Je kan daar ook in zoomen.
Oh. Zou die niet zijn, toch?
Ja, die omstaan.
Yes. Oh yeah, it's here. Okay. So like GraphQL is requesting the introspection query to give me all like when I type here, you know, the ID for example. This is all as a result from the introspection query, and it's like some.
Zoom in.
Yeah, this is right.
Zoom in.
Oh, this is the result from an introspection query. Maybe you can show the introspection query.
Oh,
itself.
exactly. Yeah, I just
Headers.
want to show like the
Headers.
the
To the bottom. And double click this. Yeah, so this is the query itself being queried.
This will give back like all the data you need to build. I really like it because you know you get a lot of data and you can build amazing tools on it. And what we've built is just like one thing which you can do with GraphQL, but the possibilities are almost endless, you know, because you can do these kind of things that which are really hard to do. And if you make a REST API, it's really hard to like enumerate every point there is without somebody documenting that. And this is just you get it back and you can do whatever you want. He made a D3 graph thing that made some big ass graph with the GitHub API. You know, I used the syntax tree for something, and we are looking into more ways how we can use GraphQL and these kind of specification, these kind of things to make new tools and kind of things that aren't really possible with REST.
It's just a query that says get the documentation.
Yes. Yeah.
And it's always there. You don't have to find it or something. You don't have to add doc blocks or JS docs like you have to do with REST or anything else. Okay. Well, I think there are questions. You raised your hand first.
Okay. Have you had any experience on how deep nested the queries can go with this left join?
Fun fact, yes, it can't really go because it will make like big ass table names, and like type ORM is what we're using as our ORM. At some point, like if you keep on joining, it will say like your table name is too large, so stop it. So it's like a sort of failsafe now, but we can we should be able to control like how deep you can go and these kind of things. That should be like easy to determine.
Was the end 5 levels deep or something, or how far could you go?
It's actually 6 levels deep or something that
I'm not sure.
When does it fail? You can just pull for another.
It shouldn't fail if you prevent the restriction on table names.
Yeah.
Oh, I think I did.
Then I think it will run indefinitely.
I think I didn't implement like the flights field on the airport, so I can't get back to the
passengers.
Recursion.
I think I did passengers. Yeah, but I'm not sure if I.
Oh, flights.
Flights. Okay, yeah, I can go.
So the question, sorry for the streamers. The question is when using the AST inspection solution, is it then limited using joins?
So I requested the passengers, its flights, and their departure airport inside flights. So I'm kind of like getting all flights, getting all the passengers, getting all their flights, and then. But this data set is small, so it's not really a problem. But you can see like here, it's getting the passengers, getting the flights, and it's getting the departure airports. And I can keep on going and doing them.
Can you show the query?
Logical to get.
Huh? Can you see the? Oh yeah, you can see the query, sure.
Rerun one more time?
No, this I think.
Is the whole query?
Let me see.
Flights is not.
No, I didn't implement the passengers the right way. For the use. So if you look at it.
Oh, the passengers.
Let me see. I'm not sure. Actually. No, it's still getting something from. I think I didn't implement the passengers right here. Oh no, it had to do with a many-to-many table. So we still have to look at how we're going to do it to join it with a many-to-many table. That's the problem. I figured it out earlier when I made this demo. But as long as you don't do many-to-manys, because typo does something special with many-to-many relations. Why?
You can use it together with a data loader, I guess, to resolve some of that.
Also, that's actually quite smart.
Yeah.
Yeah.
Well,
why not?
You should hire him. No.
No, that's true. But it should be able to do a many-to-many as well.
Yeah.
We just haven't seen one.
So that's a good point of him. You can use data loaders and this AST solution at the same time. You don't have to choose. Yes. You.
Do you have any use cases already with this and like authorization on this one?
Well, with authorization are mostly done in, at least that's what we recommend, in the resolve function on a very low level? No, high level. So when you go very deep in a query, then when you, for example, request the name of a flight of departure airports of passengers of another flight of another airport, then you're very deep, and then to determine whether a user can access that, it is determined in the level, in the resolve function of the name. That's what we recommend to do, instead of completely upfront, because not embedding the name upfront could also mean that the optimization is not applied, not that the user may not retrieve the field. So we always recommend to do it on a very high level, just close to the definition where your field is. And then you can also inspect the AST to determine whether someone has access or not. And that's something else we have to look into.
Oh,
that's
yeah, like,
that's right,
like
the same.
Scoped end-to-end or scoped many-to-many relations. You have.
Yeah, it's hard.
But maybe you can eject maybe like a user ID or something.
Yeah.
From the context or something.
Yeah, you can determine it right there, but it's just as hard as when you are using data loaders, or it's just as hard as when you're using anything else. So yeah, that's something that this solution does not resolve.
And another question: have you looked at well, basically the IDs, or that you at least get rid of resolving duplicate records? So, for example, in the example that you use with the flights and the airports, so basically it sounds like a very silly problem because you have 3 of the same airports, right? 3 queries for the same airport with the same ID. So I've been diving a little bit into the Apollo link state and stuff like that, where they got rid of Redux, and then now we have this.
So
the
question is about client-side optimization.
Yeah, they're doing this client-side optimization by looking at the ID of your types, and then basically, based on the ID, they cache the types, or they cache the records, actually.
Yeah, that still works.
So you could do a little something like that on the server side as well, I guess, right? So you only, so if you have like one airport with the same ID, so you cache.
Yeah, well, that's actually so. The question is about caching by ID on the server, and that's actually what the solution of data loaders is for.
Yeah.
So, because the data loader just collects all the IDs and then resolves them afterwards.
Yeah, but it does that all the time. It does that for every query. So there's like 3 consecutive queries doing the same thing, it will still do 3 queries. So, I mean, 3 different queries are still doing the same query to the same airport.
It shouldn't do any redundant queries when you're using data loaders correctly.
If there is multiple levels in the hierarchy, like we had the query now, where you start with flights, the airports, passengers, and then again airports.
Yep.
The date is done with the data loader. The data loader will remember, oh, I have already seen airport number 2 previously, and resolved it previously, so I'm caching it.
Yeah, actually it works quite differently because it collects all the IDs up front.
No, you cannot always resolve all
then
IDs up front because
there's
nested queries.
Sorry.
There is a nested query in what the last example is shown. You can only resolve the IDs up to so far, then you get more results, but then you cannot resolve the IDs of the airports.
Because you're not there yet.
Because you're not there yet, because you haven't resolved the passengers yet.
Yeah, that's true. That's the limitation of data loader.
But does the data loader then still cache?
No, it's you to decide that, because you can put the data loaders in like a time-based cache, but you can also put the data loaders in a request-based cache. And then every request will get a new set of data loaders to be shared within the whole query being executed in that request. But when you have a time-based data loader, then it will probably catch your problem too, because the query will be so fast that within the 50 milliseconds of resolving all the data, it will use the same cache. So even if the threshold is 50 milliseconds, then it would be really useful already. So that's up to you how you use the data loader. So maybe not by context, not by the context argument, but import it from a service which is time-based and recreates a data loader, a set of data loaders every 50 milliseconds. That's up to you. So, but it's a good point. And I think that our solution of AST introspection also tackles that problem, because it knows everything up front.
Even if the query itself is by nature recursive.
It doesn't know everything up front, but it knows which fields are being called, and it joins the queries. So you don't need to do multiple queries at all. So that's really it. Yeah, somebody else?
I want to add that it's also possible to combine data loaders with caching in the resolvers. So it's possible that you get something from the cache, and if it's not present in the cache, then data loader will query for those IDs only. So maybe if half of the flights are already loaded, then only a few of them will be loaded with one query.
Yeah.
Also, the other thing is that with the joins, I would be a bit more careful, because it also means retrieving more data from the database, and also sometimes some joins can be really heavy depending on your databases, and then actually the data loader method is much faster. Maybe if you use some relationship MySQL or whatsoever, then I would first really test which one works the best.
Yeah. So the point he made is that you always have to look what the best solution is. It's not one holy solution, and that's really true. Okay,
But is there a way that you can manage that on query level with your solution?
You can manage that on any level of fields. It doesn't matter how deep we are.
No, but you can choose whether you want to use the data loader solution or the join solution. That would be super interesting, because then you can just look at performance and then choose based on the queries that you have.
Yeah, that decision should have been made on the lowest possible level, because that's the location where you decide whether or not to join tables up front. That's where you have to decide whether or not you do that, and then in a deeper level you can always call the data loader.
You can do a lot of fun things. Like we are doing joins right now, but we could also make select statements on the fields that are queried, right? That's probably going to be a next step.
Yeah.
And
that is super interesting.
The main point is like, okay, we have that syntax tree, and we can do so much amazing things with that.
Yeah.
And just like the joins in this case, it's something we created quite recently, and it works pretty well for us right now. But of course, we have to iterate on that and create a way better version.
That's really interesting, but it also sounds like a problem that a lot of ORMs also have, right? And ORMs usually have the two cases. So you have the case where you basically say, I want to do it with the select. I'm going to select all the IDs that refer to another table, and then use that as a select query for a second query, or I'm going to use inner joins if I'm sure that I want to use both tables.
Yeah.
And the left joins, yeah, they create a lot more overhead, I think.
Yeah, so the get query from GraphQL info function could get a lot more smarter, but that's what he said. It's just has to evolve. Okay, so I want to wrap up the presentation, and well, there is a show and tell from Kim over there. He will show something about some GraphQL tools, and if there are any other people who want to show and tell something, I think that's possible. So let's take a little break first, just a few minutes to grab a drink, and then we will resume with this talk. Thank you.
Guys, hi, my name is Alex. I want to make two little announcements. So we are running Binder.js Builds meetup group, and we are super happy to have you here. There will be one more meetup that we are planning together with Tech Leads meetup group, the group that was just created. We are planning the kickoff event next Wednesday. So if you are senior chapter leads, tech leads, whatsoever, consider coming next Wednesday to Binder. That's the first thing. Second thing, I'm really happy to see that the GraphQL community in Netherlands and Amsterdam is growing, and I think this event is a beautiful confirmation that the community is growing, and thanks to Lifely for having this event. So we are really passionate about helping the community to grow and contributing to the community. And saying that, I want to maybe tell you, maybe you haven't heard about it yet, there will be GraphQL Europe conference in Berlin in 15th of June, I believe. They just released early bird tickets. I'm not sure, I believe it's like 199 euro. I talked to organizers, and one of the organizers is GraphQL, right? They said that there is no promo code so far. Most likely price will not go down. So if you are considering to convince your employer to send you to a GraphQL conference, I think this is the right moment to do it. Now we will start the show and tell, and Kim will start this part of the evening, and Kim is author and contributor of many GraphQL libraries. So he's one of the most experienced people in the GraphQL ecosystem. So we will have a little introduction, or maybe a big introduction to GraphQL ecosystem. And I'm very happy to have Kim tonight. So after Kim, please join and come stage and talk about what you've done or what you think about GraphQL.
Thank you, Alex, for your kind introduction. Yes, my name is Kim Brandwijk. GraphQL developer and enthusiast. I've been working on several tools in the GraphQL ecosystem for the past 6 months, roughly. And one of the things that we noticed when working on these tools is that there's a lot of investment going on in the client-side tools, with Apollo client and everything they're doing on the client side, React, Relay. A lot of that stuff is all happening on the client. But building a GraphQL server yourself and having a great development workflow around that, and a great development experience, there was a lot lacking in that area. So mostly driven by the initiatives from both Apollo and GraphQL. We really decided to invest in that over the past few months to really get to that, build your own GraphQL server to make that a very smooth and easy experience also for starters. So that's the reason why I want to share a little bit of that with you. First of all, who has ever built his own GraphQL server? And have you all used Apollo server for that or other? Mostly Apollo. Other, Sangria?
I've seen. I've seen.
Okay. So, was that an easy experience overall, or? Oh. I'm going to show you. This is my current toolbox for building a GraphQL server. It contains tools ranging from CLI tools to configuration tools, two tools for actually running your GraphQL server, and I'm going to get to those in more detail. But first, I'd like to show you how that's all connected. So this looks like a very very complicated picture, but it really isn't. In the middle, we have our GraphQL server, and we create it using a boilerplate. I'll show that in more detail. We use bindings to existing GraphQL endpoints because 9 out of 10 times we're not just concerned with building our own GraphQL server with a database underneath it. Most organizations will have existing endpoints, whether they're GraphQL endpoints, REST APIs we've already seen earlier tonight. So I'm going to show you a little bit about that. And in the end, we're going to actually deploy and use our GraphQL server. So let's take that step by step. First step is, what's the easiest way to get started building your own GraphQL server? And one of the things we did is we came up with a number of GraphQL boilerplates, which are basically ready-made GraphQL server projects that you can easily start. Some with JavaScript, some with TypeScript. There are currently 6 down. You can see them here. Some full stack examples, some backend only. But that gives you a great starting point for setting up your own server. And the tool that we're going to use is the GraphQL CLI. And if you know the GraphQL CLI? No? Okay. The GraphQL CLI contains a lot of commands for working with GraphQL endpoints. So it contains commands to download schemas from a GraphQL server. It contains commands to set up a new server, add endpoints to an existing configuration. So it's a very versatile tool. And it has one command, GraphQL create, that basically takes that boilerplate and installs it for you. And what most of the boilerplates also contain is a Prisma, formerly known as GraphQL service, which is basically a backend as a service platform for specifying a GraphQL schema. And what it will do for you when you deploy that schema, it will actually create a database using AWS Aurora, and it will give you a full thread API and subscription API. So just based on a simple GraphQL schema, it'll take a lot of work out of your hands. So that's also very useful if you're getting started, you want a quick getting started experience, setting up a database and having a GraphQL endpoint for it. Okay, so taking that boilerplate and installing that, what we'll get is we'll get a configuration file from GraphQL config, and this configuration file basically determines all of your endpoints. So we have an app endpoint here with a schema. We have a backend database with a schema as well, and we have some other endpoints defined here. So this is just a quick sample configuration file. And the next thing we need to define our GraphQL server is a schema definition, of course. And I saw in the previous examples a little bit of a different notation. I'd like to use the schema definition language, the SDL notation, because I think it's a bit easier to read. And most of you will probably be familiar with the bottom half of this, defining a query, defining your types. And most of you will probably wonder about what's going on there at the top. One of the tools we developed is GraphQL import, and what that allows you to easily do is take types from existing schema and import those into your own GraphQL server schema. So in this case, let's imagine we're connecting to, in this case, a Bahnhof endpoint, which is a German train operator. And we want to import the type station from it because we're using it in our own schema and we don't feel like redefining or copying it. We can just import it right there. And what the result of this actually is, and I had to make it very small. You can still, it's still not everything. This is the resulting schema of those simple imports. Why? Because the station has other fields, and those fields have types, so it's really like a recursive import of all the types you need. So that makes defining your own schema nice and simple and very clear to use, and it will give you all the types you need to actually run your server. So that's GraphQL import, a very useful tool. And what you'll also get out of most of the boilerplates is your basic, very basic implementation of a GraphQL server. For those of you familiar with Apollo Server, this uses GraphQL Yoga, which is basically a layer on top of Apollo Server. So underneath, this is using Apollo Server, but it's providing you with a number of extras out of the box, like easy support for subscriptions, easy support for just defining your type definitions and resolvers, and have your server up and running. It will also come with a built-in playground, so similar to GraphQL. I'm going to show that one later. And it's going to come with a built-in subscription endpoint. So basically all you need is this amount of code, and you have a basic server running with the schema we just defined. Okay, next I said there's a possibility that you might want to connect to an existing endpoint. Just not directly calling a database in your resolvers, but using an existing GraphQL API or the GitHub API, for example, or the Prisma service, the GraphQL API that it gives you. So all of those are possible with another invaluable tool, which is GraphQL bindings. And what GraphQL bindings does is basically it's your ORM tool for GraphQL. So you feed it a GraphQL schema, any GraphQL schema, and it will generate, based on the language you use. If you use TypeScript, it will generate TypeScript type definitions for you, and it will also create a class that gives you easy access to all of your queries and mutations and subscriptions that are part of the schema. Now, if we go back to the config file we used before, you're going to notice we have here a prepare binding section, and that's actually what configures those bindings. So it's going to define, I want a TypeScript file as an output, and I want to use a specific generator. There are currently generators for JavaScript and TypeScript, for regular GraphQL endpoints, and for Prisma GraphQL endpoints. And what that gives you, this is a sample of the schema we're going to feed it. Just types, mutations, and other things you're used to in schema. And what that will give you is TypeScript type definitions. So all of your schema, all of your queries, your mutations, all of the individual types, all of your argument types, they're all generated for you as TypeScript types. And what it will also give you is that class that I talked about, based on a base class, that exposes all of your queries and all of your mutations as methods on the class, so you can easily call them. So what's the benefit of that? You get full type safety, not only for the name of the query, but also for all of the arguments when using this in TypeScript. So that's very valuable. Makes it really easy to talk to an existing GraphQL API and execute queries against it. So those bindings that we just looked at, it's going to be as simple as adding them to the context of our server. We've seen in the previous presentation the context is shared across all resolvers of your server. So we're going to add those to the context, and then implementing, for example, the reviews resolver is going to be as simple as just calling our endpoint, calling a query on it, and saying we want all of the reviews in this case with certain arguments. That's all that's needed to talk to that existing GraphQL API, and all the other details are abstracted away and easy to use. It can get even more easy if you just want to directly forward a call to an existing query. In this case, we're directly using the create review mutation, and all that's needed is to define forward to and specify the name of the endpoint, and that's all you need to specify to implement this resolver in your own GraphQL server and make sure it gets forwarded to the existing GraphQL endpoint. So bindings, basically the possibilities are endless. There are a few basic functionalities like this in the base classes, but it's very easy to extend. For example, there's a GraphQL binding specifically for GitHub that just asks you for your token, basically, and exposes the entire GitHub API like this. There's going to be a GraphQL binding Open API that we're working on now, where you can feed your Swagger or Open API definition to it, and it will actually generate the full GraphQL schema for it. So a lot of possibilities there that we're going to explore over the coming period. There's one type of binding that I want to highlight, and probably, who knows this logo? None of you? Great. This is the logo of Gramps. Gramps is a tool that's recently developed by IBM. They wanted a way to, within their organization, within large teams, they wanted a uniform way to share data sources. So what they made Gramps, and what that does is it takes any data source and packages it as a GraphQL schema, as an NPM package. So if you need any data source, you just install the package, add the binding that's exported from it to your server, and that's it. And so you really don't need to be concerned with the details, the implementation details of that data source. It could be a REST API, it could be a database, it could be anything basically. You don't need to be concerned with it. You just install the package and use the standard format they define for the export, and you're ready to go. So that's especially within organizations where you have different teams in charge of their own endpoints within the organization. It's a very valuable tool to share those. I'm going to skip the deploy part, but I do want it to show you this. This is the GraphQL playground, better described as GraphQL on steroids. For everyone using GraphQL now, I would strongly advise you to have a look at the GraphQL playground. The basic functionality is the same, but it offers a few nice extras. First of all, it's compatible with a GraphQL config. So if you have that configuration file that we showed in the beginning, where you have a number of endpoints or a number of different GraphQL APIs in your project, what that gives you is easy access to those from a single playground. So, for example, this is the gateway endpoint, so that's your public GraphQL server that you're building, but it's very easy during development to switch to one of the underlying endpoints and just query it directly. So it's very easy to do testing on it. So that works very well. Another useful feature is support for tracing. Tracing was introduced by Apollo in their GraphQL tools. they have something called Apollo Engine, which does both caching and tracing, and gives you historical tracing information and all kinds of useful things. But it's a semi-free service, basically. After the first 1 million requests, we start paying for it. So we decided to put at least minimal tracing support in the playground. So what you can see here, based on the query you've run, is for each level how long it actually took to retrieve. So it's very easy. If we would use this playground for the previous example with the SQL query optimization, it would be very easy to see the differences in tracing information between running multiple requests and running one combined request. So that's very helpful. Also, it's available as both as an Electron desktop app and a browser version, and it's also available as middleware for Express, Goa, API, Lambda, so you can easily integrate it in your own server. And it's also available as a React package if you wanted to integrate it in your own app. So that's another very useful tool. Now, I promised I would keep this in 10 minutes, so I'm going to quickly go back to this overview and then leave you with a set of links. Whenever this is published, you can have a look at all these individual packages in more detail. If you want to find me, you can find me on GitHub with my tag, or you can find me on either the Apollo or GraphQL Slack channel if you want to discuss anything related to this. So, any questions?
Applause first.
Are there any plans to make the playground mobile compatible? At the moment, it's very unhandy to use it on a phone, but we actually like it much better than the GraphQL API, but that's the only problem, that on mobile it's almost sometimes impossible to type the queries.
Okay, I'm not sure if that's already one of the known issues. I know there's been a lot of feedback on the GraphQL playground, and there's continuous work going on to improve on that. So I would suggest you to look it up on GitHub and see if that's already one of the reported issues. And if not, please report it, because then it will definitely be attended to sooner or later. Any other questions? Okay, then that's it for me.
Go. Anybody else would like to share something about GraphQL? Ask a question or raise a concern, raise an issue? No? Nothing to show, nothing to tell? Okay, then thank you guys for coming here, and let's continue with networking. Do you have some other maybe
Ja, hij heeft ook zelf.
Ah, vale, joder. Pero dijo que se va
Oh, 7 kilometers, that's not too far. It says 30-minute bike. It's not too bad. It says 31 minutes. I'll probably get lost like 12 times.
research more about that.
I'm going to stick around for
La acabo de recibir.
I've lived in a couple cities in Canada, but they've all been Halifax would have been the biggest one, and it's still quite small. I don't even know what the population is. But that's for like British for Sydney, which is really small, and then like the surrounding area. So I don't know the actual city itself population, but it was really small. Like I would run into the same people a couple times a day. Is that it? I thought it was bigger.
That's